Okay, so let's talk about AI. It feels like it's everywhere, right? And honestly, it can seem super complex, maybe even a little futuristic. But what if I told you that the basic idea behind it is actually pretty straightforward? Well, today we're going to pull back the curtain. We're going to break down how AI really works step by simple step. Ready? Let's dive in. All right, to really get AI, you have to understand this one massive shift in how we talk to computers. In the old days, and I mean what most programming still is, you'd write the rules yourself. You'd tell the computer, if this happens, do that. Step-by-step instructions. But with machine learning, which is the engine of modern AI, we flip that whole thing on its head. Instead of giving it the rules, we give it a ton of examples. We show it the data and the answers we want, and we say, you figure out the rules. It's kind of like, instead of giving you a detailed recipe for a cake, I just give you the finished cake and a pantry full of ingredients and say, go on, figure it out. That's the core idea. So you've probably heard all these buzzwords, right? AI, machine learning, deep learning. They get thrown around like they all mean the same thing, but they don't. So let's build a quick family tree to get the lingo straight.
Okay, first up, the big one, artificial intelligence, AI. This is the whole field, the big picture dream. It's the grand idea of making machines that can think, problem solve, and learn. Do all the smart stuff we humans do. And the best way to picture how all these terms fit together? Think of those Russian nesting dolls. You've got the biggest doll on the outside. That's AI. It's the whole shebang. But when you pop it open, you find the next doll inside. Machine learning, or ML. So this is super important. ML isn't something different from AI, it's a type of AI. It's a specific way we're trying to build that intelligence by having machines learn directly from data instead of us programming in every single rule.
And what happens when we open up the machine learning doll? We find an even smaller, more specialized doll inside. That's deep learning. Now, this is a super powerful kind of machine learning that uses these things called artificial neural networks. We're going to get into what those are in a sec, but they are the secret sauce behind some of the craziest AI stuff you see today, like understanding what you're saying or finding your face in a photo. All right, so that leads us right to the heart of the matter, the engine that's driving almost all of this modern AI progress, the neural network. This is the deep part of deep learning. Let's crack open this digital brain and see what's going on inside.
And what's so cool about this is where the idea came from. It's not just some random computer science thing. It's literally inspired by biology. They're called neural networks because they're designed to mimic, in a very simple way, how the neurons in your own brain connect and talk to each other. It's a really foundational concept.
Okay, so here's a picture of one. Now, don't get hung up on all the lines and dots. It looks complicated, but the idea is actually pretty simple. You have layers of these little nodes, which are kind of like digital neurons. Information comes in on one side, gets passed through these middle layers where all the processing happens, and then a final answer comes out the other side. That's it. The whole structure is just a really, really good pattern-finding machine. Let's walk through that flow. Think of it in 3 steps. Step 1 is the input layer. This is like your eyes. It takes in all the raw information, like, say, every single pixel from a picture. Then comes step 2, the hidden layers. This is where the magic happens, the thinking part. The first hidden layer might spot simple things like edges or corners. The next layer might take those edges and corners and see shapes. The next one might see ears and whiskers. See how it builds up? And finally, step 3 is the output layer. This is the part that gives you the final single answer, like, yep, that's a cat. So it's cool that we have this digital brain structure, but how does it actually get smart? Because a freshly made neural network is basically like a newborn baby's brain. The parts are there, but it doesn't know anything yet. It has to learn. It has to be trained. So how exactly does this thing go from being a total blank slate to something that can, actually do useful stuff? How does it get smarter? Well, just like us, it learns from its mistakes. A lot of mistakes.
The secret is a process with a fancy name, backpropagation. But here's all it really is. You show the network a picture of a cat, and it makes a guess, say, dog, because at first it's just guessing randomly. Backpropagation is basically the feedback loop where you tell it, nope, wrong, that was a cat. The network then literally goes backwards through its own connections and adjusts them ever so slightly, making it a tiny bit more likely to guess cat the next time it sees something similar. Now imagine doing that 1,000,000 or 100,000,000 times. It's a slow process of tiny corrections that eventually makes the network incredibly accurate. This idea, this simple feedback loop, is probably the single biggest reason AI has exploded in recent years.
And this is what that process looks like. It's a total before and after story. On the left, you have the before, the untrained network. Its connections are a random mess. Its predictions are just wild guesses. And its error rate? It's sky high. But on the right, after all that training, after millions of those tiny corrections, the connections are optimized, the predictions become accurate, and look at that error rate. It just drops right down. The network has actually learned the pattern.
Okay, we've been deep in the weeds with the mechanics. Let's zoom back out. What does all this technical stuff have to do with the AI you actually use every day? And what's the one thing it absolutely needs to work?
Well, that whole training process we just talked about, that's the engine behind pretty much all the AI you bump into. You know when Amazon or Netflix recommends something you actually want to watch? That's AI that's learned patterns from millions of users. When you upload a photo and it automatically suggests tagging your friends, yep, that's an AI trained on countless faces. Fraud detection on your credit card, virtual assistants answering your questions, instant language translation, it's all powered by this exact same idea. It's already everywhere.
Now, I know this can start to feel a little bit like magic, but it's really not. Under the hood, it's all built on a solid foundation of, well, math. You've got things like linear algebra for organizing all the data, calculus is what makes that whole learning from mistakes process work, and probability theory helps the AI deal with things that aren't black and white. So again, it's not magic, it's just very, very clever math.
And that leads us to maybe the single most important rule in all of AI, the one thing you have to remember. An AI is only, and I mean only, as smart as the data you train it on. Data is its food, it's its fuel, it's the only world it has ever known. So if you feed it biased, incomplete, or just plain bad data, you're going to get a biased, incomplete, and bad AI. It's that simple. All the amazing AI we see today exists because of one thing: massive, high-quality data sets.
So when you boil it all down, what is AI? It's not magic, it's not a thinking being, at least not yet. It's powerful pattern recognition, just scaled up to a level that no human brain could ever handle.
Which leaves us with a pretty mind-bending thought to end on. We just established that data is the fuel for AI, and our world is creating more data every single second than at any point in human history. So, if the fuel for AI is practically infinite and growing all the time, what does that mean for our future? What happens next? Definitely something to think about. Thanks for joining me.